what actually is time? The time paradox scares scientists, and there is no solution. Researchers have found ways to describe time, but in fact it remains one of the most mysterious quantities in the universe and often defies the logic of the mind. Time takes us into completely new dimensions and into crazy scenarios that sound like something out of a science fiction novel, but are actually quite normal physical facts. From a scientific point of view, time is a dimension that describes the sequence of events from the past to the present to the future. It's closely linked to space and the speed of light. We live in a spacetime continuum consisting of a space with length, height, and width as well as events that take place within the definition of time in this space. The speed of light describes the speed at which light moves through space, and it is the only known constant force in the universe and the quantity that connects time and space. This all sounds logical and plausible so far, but time is a crazy dimension that made Einstein's head spin. Is time the same everywhere in the universe? Imagine a world in which time is not constant but changes depending on where you are in the universe. Does that sound like science fiction to you? But it is actually a reality that is supported by the laws of physics and in particular by Einstein's theory of relativity. Albert Einstein's special theory of relativity introduced a revolutionary idea: time is not absolute. It depends on your speed relative to other objects. If you are moving very fast, close to the speed of light, time slows down from your perspective compared to someone who is moving slower or not at all. This phenomenon is known as time dilation. It has been confirmed by experiments with clocks in fast-flying airplanes as they clearly ran slower than clocks on the ground. It becomes even more fascinating in Einstein's general theory of relativity. Gravity plays a central role here. Strong gravitational fields, as they occur with large masses such as planets or stars, can also influence time. The closer you get to an object with strong gravity, the slower time passes. This has been proven, for example, by clocks on satellites compared to clocks on Earth. These findings not only influence our understanding of time travel and black holes, but also practical applications such as the GPS system, which actually includes corrections for the relativistic effects of time dilation and gravitational time dilation. So time is not fixed, but a dynamic and flexible construct that depends on your movement and position in the gravitational field of the universe. The idea of a universally constant time is an illusion. In the world of modern physics, time is only an illusion of our consciousness. Imagine that time is, in fact, an illusion, a construct of our consciousness that has no real basis in the fabric of the universe. This bold thesis raises the question of whether we could then change the past or look into the future. The idea that time is an illusion stems from the philosophical view of time and is also discussed in some scientific theories. In physics, time is often regarded as a fourth dimension alongside the three dimensions of space. But unlike space, which is perceived as something tangible, time is far more elusive. Some theories of quantum mechanics and cosmology suggest that time may not be as fundamental as we think. In the quantum world, for example, some processes appear to be time-dependent, and the theory of quantum gravity often attempts to explain time as an emergent phenomenon in practice, something that only arises at higher levels of complexity. The idea that time is an illusion could also mean that the past, present, and future exist simultaneously. This concept is known to scientists as the block universe, in which the past, present, and future are fixed and unchanging. But could we then look into the past or future and even change them? According to our current scientific understanding, this is not possible. Time travel into the past raises paradoxes that we will look at in more detail in a moment. Seeing the future would mean that the universe is completely deterministic, which contradicts the natural laws of quantum mechanics. Does a hidden dimension of time exist? Have you ever considered that a hidden dimension of time exists, similar to a fabric or carpet that runs through space? This idea is provocative and intriguing, and it could theoretically provide answers to some of the universe's greatest mysteries. At the moment, the idea of an additional dimension of time goes beyond our everyday understanding of time. In classical physics, time is considered a one-dimensional linear quantity, despite its crazy properties. But in theoretical physics, particularly in string theory and other approaches to quantum gravity, the possibility of additional hidden dimensions is becoming a reality, and time could be one of them. Imagine spaceships one day simply gliding through space via the dimension of time and traveling great distances in a short time. Sounds like science fiction, but it's not impossible. Are we on the verge of discovering time travel? The magical thing about the idea of time travel is not only the curiosity to experience past or future eras, but also to possibly change the present by influencing the past. The possibility of time travel has fascinated mankind for a long time, and there have been serious considerations in theoretical physics. Einstein's theory of relativity states that time is relative, depending on speed and gravity, and it's precisely this that theoretically opens the door to time travel. In particular, general relativity allows for solutions that could enable time travel into the past, such as wormholes or tunnels in the spacetime continuum. Current research in areas such as quantum mechanics is already providing completely new insights into the nature of time, and the boundaries of space and time may soon be overcome. Can you destroy your existence by traveling through time? Voila, it's 2051 and time travel has become possible. You could travel back in time and meet your own grandfather before he has children. What would happen if you accidentally prevented him from having offspring? This thought experiment is known as the grandfather paradox and represents one of the greatest challenges in the theory of time travel. The grandfather paradox occurs when a person travels into the past and takes actions that would prevent their own existence in the future. For example, if you traveled back in time and prevented your grandfather from fathering your parent, then theoretically you would never be born. But if you were never born, how could you travel back and meet your grandfather? However, this paradox only occurs in classical physics. Quantum physics already has a solution. A new dimension and a new timeline will simply be created in which you will not exist. Your reality, in which you were born and were able to travel, will still remain. Here we again encounter the idea that past, future, and present are simultaneous, and the idea of quantum mechanics that several variants of reality exist side by side. One twin has aged, the other has not. Imagine you have a twin and one of you takes a trip through space at almost the speed of light while the other stays on Earth. When the traveling twin returns, he is surprisingly younger than his sibling. This fascinating scenario is known as the twin paradox and is a core principle of Einstein's theory of relativity. The twin paradox arises from the special theory of relativity, which states that time passes more slowly for objects moving at high speed than for objects at rest. In our example, a twin is traveling in a spaceship at close to the speed of light. Due to the high speed, this twin experiences time dilation. Time passes more slowly for him than for his twin on Earth. When the traveling twin returns to Earth, he realizes that more time has passed on Earth than for him in the spaceship. The result is that the traveling twin has remained younger than his twin who remained on Earth. This paradox seems to contradict intuition as it's difficult to imagine that time can pass differently for two identical people. The twin paradox has been confirmed by experiments, for example, by comparing the time on precise clocks in fast-flying airplanes with clocks on the ground. Does time travel create causal loops? Let's go on another fictitious time travel together. You travel to the past and bring back an object or knowledge that plays a decisive role in the past, but this object or knowledge actually has its origin in the future. This scenario describes the bootstrap paradox, also known as the self-consistency paradox. Closely related to this is the predestination paradox, where your actions in the past inevitably lead to events that cause your original time travel in the first place. The bootstrap paradox creates a causal loop in which an object or piece of information appears to exist without an origin. A classic example would be when a time traveler takes a book back in time and gives it to a young author who then publishes it. It's the same book the time traveler originally had. Where did the book originally come from? The predestination paradox takes this idea even further. Here, the time traveler's actions in the past lead to the circumstances that make his own time travel in the future possible. An example would be if you traveled to the past and unintentionally triggered the events that lead to your birth or your decision to travel through time. Both paradoxes raise intense questions about causality and the nature of time. They show how time travel in theory can lead to logical contradictions and infinite loops in the world of theoretical physics and science fiction. They lead to fantastic works and exciting discussions, but in the real world, they remain unsolved mysteries. Every action you take changes the big picture. Imagine again that you could travel back in time and change something there. How would this affect the present and the future? This scenario describes the paradox of the altered past, which goes a little further than the well-known grandfather paradox and raises even more questions about time travel and causality. The altered past paradox deals with the effects of any changes in the past through time travel. It deals with the idea that even small changes in the past can lead to large unpredictable changes in the present, a concept only referred to as the butterfly effect. Strictly speaking, your arrival in another time would already lead to massive changes due to the incredible chains of causality on Earth. Each of your acquaintances and actions in the past changes them. While the grandfather paradox raises a direct logical contradiction because you cannot exist to affect your grandfather if you prevent him from having descendants, the altered past paradox raises a slightly different set of questions. What happens when you change the past? How does this change the present? Do multiple timelines or parallel universes need to be created to accommodate these changes? Or has your time travel always been part of the block universe's predetermined timelines? Subscribe to the channel now and be part of every new video.